Okay, so for this problem, we are told that we have a wave with a period of 10 seconds that is in water depth of 300 feet. And then the problem asks us to find C, the single wave celerity or single wave velocity for the wave. So whenever we have these wave problems, we're always going to do them the exact same way. We're first going to solve for L naught, the deep water wavelength, and then we're going to find what the depth divided by L naught comes out to, and that'll help us classify the wave. And then once we have the wave classification, we'll go ahead and solve for whatever specific wave characteristics the problem asks us to find. So here's what that'll look like. So for the deep water wavelength, it's always equal to the acceleration due to gravity times the period squared divided by 2 pi. So for this, we're given the depth in feet, so we're going to go ahead and do everything in the English system. So g is 32.2 feet per second squared. The problem tells us that our wave period is 10 seconds, and then all over 2 pi. Now, I know this is going to sound kind of dumb, but when you're plugging in these values to solve for deep water wavelength into your calculator, you got to make sure you're going to do 32.2 times 10 squared divided by 2. And then where people make a mistake a lot of the time is they hit divided, and then they hit 2, and then they hit pi, and then they hit enter. And due to order of operations on your calculator, instead of dividing by pi, that's going to multiply by it. So you're going to end up with an answer that's about 10 times higher than it should be. So the ways to get around that, obviously you either do divided by parentheses 2 pi or divided by 2 divided by pi. And I know this sounds dumb, but if you're not careful about this, you will end up with answers that are wrong at least once, promise. All right, so if you plug this all into your calculator correctly, you end up with a deep water wavelength of 512.5 feet. So that tells us that the wave we are looking at when in deep water has a wavelength of 512.5 feet. So next up, we're going to look at what is the depth divided by the deep water wavelength. So we're in a depth of 300 feet of water divided by 512.5 feet. Plug that into your calculator, and you get 0.58. So our D over L is greater than 0.5, therefore we are in deep water. Now, if you look at your equation sheet, you'll see that there are different equations to solve for single wave celerity, group celerity, and wavelength, depending on what kind of what classification of wave you have. And if you look under deep water, it'll tell you that the wavelength is equal to the deep water wavelength. That makes sense. We solved for the deep water wavelength. We are in deep water, therefore they're the same. Awesome. Now, if we want the single wave celerity, it tells us that that is equal to g times the period over 2 pi. So we can go ahead and plug in 32.2 feet per second squared times 10 seconds all over 2 pi. Plug it all in, and you get 51.25 feet per second. Right, and that's all there is to these problems when they're deep water.